Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. So right here, we have 4 to the power of 100 minus 4 to the power of 99. And we want to find the value of this expression. So what we're first going to do is we're going to rewrite 4 to the power of 100 as 4 to the power of 99 plus 1. All we did was we changed the 100 to 99 plus 1, and that is true. And we're going to keep the 4 to the power of 99 as is. And now what we're going to do is we're going to use a useful exponential property. So let's say we have a to the power of n plus n. Well, this exponential property states that this is equal to a to the power of m times a to the power of n. Because remember, when we're multiplying exponents with the same basis, all we do is add the exponents. So what we're simply doing is we're reversing this rule. So what we're going to do to this 4 to the power of 99 plus 1 is we're going to rewrite this as 4 to the power of 99 times 4 to the power of 1 minus 4 to the power of 99. We're keeping that same. All right. So now, as you can see, we have two 4 to the power of 99s. And what we're going to do is we're going to factor 4 to the power of 99 out to simplify this a little more. So we're going to do 4 to the power of 99 times, well, 4 to the power of 99 times 4 to the power of 1 divided by 4 to the power of 99 is simply just 4 to the power of 1 minus 4 to the power of 99 divided by 4 to the power of 99 is simply 1. And as we all know, 4 to the power of 1 is simply 4. So we have 4 minus 1 times 4 to the power of 99. And 4 to the power, 4 minus 1 is obviously 3. So our answer is 3 times 4 to the power of 99. This is our answer. And if you want, you can plug this into a scientific calculator. Normal calculators actually don't have digits this high. So yeah, we actually can't find the exact answer of this because that number is too big. It has way too many digits. But this is also an exact answer, just not exact, if you will. And that's how you solve this exponential problem. Welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem without a calculator. So we have 5 to the power of 5 times 4 to the power of 7. So what I'm first going to do is I'm going to rewrite this as 5 to the power of 5 times 4 to the power of 5 plus 2. Now, an important property of logarithms is that if we have a to the power of m plus n, this is the same thing as a to the power of m times a to the power of n. So if we have 4 to the power of 5 plus 2, this is the same thing as 4 to the power of 5 times 4 to the power of 2. Because 5 in this case is m and 2 is n. And we're still multiplying this with 5 to the power of 5. Now, another property of logarithms is that if we have a to the power of n times b to the power of n, this is equal to a times b in parentheses to the power of n. So right here we have 5 to the power of 5 times 4 to the power of 5, and 5 in this case is n, and 5 and 4 are a and b respectively. So this can be converted to 5 times 4 to the power of 5 times 4 squared. Now 5 times 4 is 20, so now we have 20 to the power of 5 times 4 squared. Well, 4 is the same thing as 2 to the power of 2. So we have 2 to the power of 2 to the power of 2. So now we have 20 to the power of 5 times 2 to the power of 2 to the power of 2. Now, if we have something, now this is actually another exponential property, but if we have a to the power of m to the power of n, so if we have a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of 2, this is the same thing as 2 to the power of 4, because we're simply multiplying these two. And I'm going to rewrite 20 as 10 times 2. So we have 10 times 2 to the power of 5 times 2 to the power of 4. So now, remember, we're going to use this property, a to the power of n times b to the power of n equals a times b to the power of n, but we're simply reversing it. So we're going to convert this form back to this form. So a times b to the power of n, so 10 times 2 to the power of 5, this is the same thing as 10 to the power of 5 times 2 to the power of 5. And we're still multiplying this with 4. And now remember this property, when we're multiplying two exponents, we add our exponents. So 2 to the power of 5 times 2 to the power of 4, this is 2 to the power of 5 plus 2 to the power of 5 plus 4, which is 2 to the power of 9 times 10 to the power of 5. Now, 2 to the power of 9 is equal to 512. And 10 to the power of 5 is simply, when we're multiplying something with 10 to a specific power, we're simply adding the exponent amount of zeros to that number. So we're going to add 5 zeros to 512. So we have 1, 2, 3, 4, 5. So this here is our answer to this problem.